Okay, we're on to ellipses today. An ellipse is a set of all points whose distance from two foci sum to a constant. Set of all points whose distance from two foci sum to a constant. So again, it's not simply just you take a cone and you cut it at an angle and get an ellipse shape. That's not the definition mathematically. But as we use this definition to come up with the actual equation. If I wanted to make a circle, I'd put a point on the board. I get a string the length of the radius that I would want. And on one end, I'd put it at the point. The other end, I'd attach a marker, and I'd go around, right? I get a circle. Well, ellipses are very similar to circles in the way that they're created. There's just a small difference. Okay. Playground after school, 3 o'clock. Black and tell them to step up. Okay, here we go. So, suppose I put 2 points down. Instead of 1 point, I put 2 points down. Instead of the center of a circle, I put 2 focal points. And instead of a string that is not tied at either end, I tie the ends together. And I loop the string around these 2 focal points, and I stretch it out as far as it goes. Okay, at that end spot will be a point. And as I continue to stretch that string out and carry it around and around, I will get, a potato. Okay? I'll get an ellipse. But here's the deal. This distance of the point from the first focus and this distance, second distance from this point to the other focus, if you take those and add them up, they're going to sum to a constant number, say 36. I don't know. But yeah, but it won't actually go around. I mean, it's just expanded. That you don't get the idea. You know what I mean? I used to, when we had more time, we would take somebody's shoestring and we would do this on the board. It was a good time. People would laugh. Yeah. We don't have time, so we do this instead. The equation for the ellipse is right here. We have x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. And in this situation, we say that a squared is greater than b squared. So you could also have an ellipse that looks like this. X minus h quantity squared over b squared plus y minus k quantity squared over a squared is equal to 1. So for ellipses, a squared is always the larger value. That's important because if a is larger and it sits under x, then it's stretched more horizontally. If a is larger and it's under y, then it's stretched more vertically, as you can see in the drawings that we have. Nobody got this third hour, but I don't know how hard they were trying. Can somebody please tell me, what do you think the center is of the ellipse? Suppose that it's not centered at 0, 0, and it's shifted. What would be the center? Looking at HK. Thank you. So the center of the ellipse will be HK. In our drawing here, you can see that we do have listed 0, 0. We'll call it HK. The vertices are the endpoints of the ellipses when it's stretched the most in whatever direction stretched the most, okay? So top and bottom here and left and right over here. The nice thing about these vertices is they are exactly A units from the center. Suppose my center was 0, 0. What would be the vertices for this ellipse. So 0 plus a would be a, and 0 minus a would be negative a. So the vertices would be plus or minus a, 0. Suppose that it was shifted. Would the shift affect the h value or the k value if I move a units left and right? It would affect the h. So if it's shifted, it would be h plus or minus a, and the k value would be the same. Let's switch and look at one that is vertical. Suppose the center is at 0, 0. What would the vertices be? 0 plus or minus a. So if it's shifted, will that affect the h value or the k value? The k value. So it would be 0, I'm sorry, h, and then k plus or minus a. The length of the major axis is the distance from one vertex to the other. What is the distance from one vertex to the other? Twice the a value in both situations. The minor axis is the distance between the other sides, and it's stretched b units in each direction for the minor axis. So what is the length of the minor axis? B. The foci sit along the major axis. Foci are 2 points, and they sit exactly c units from the center. If the center is at 0, 0, what will be the location of the foci? Yep, plus or minus c, 0. If it is shifted, will that affect the h value or the k value? H, so it will be h plus or minus c, k. And just the opposite for the other side. If it's vertical, then be 0 plus or minus c, and that will affect the k value. And the last piece we talk about is eccentricity. Eccentricity is a measurement for how stretched the ellipse is. It is the measurement for how stretched the ellipse is. And in this situation, to be able to determine a number for eccentricity, we take the c value and we divide it by a. The closer that the eccentricity value is to 1, the more stretched it is. The closer it is to 0, the more it will just look like a circle. What do you study in science class that might talk about ellipses? The orbit of the planets or moon or something like that, right? And from ancient times, say 500 BC, we have records that mathematicians, a great development in mathematics was to understand astronomy. And from very early on, we can tell that they understood that the orbit of the planets was probably not circular, but rather elliptical. Okay? There's a lot of applications for ellipses in this world. We just give a very brief introduction to this piece. Conic sections, we could really spend a good month on it. We'll spend about a week and a half. Let's graph it. Sketch a graph of the following. Find these following pieces. I'm going to add to it. We're going to look at direction. We're going to look at center. We're going to look at vertices, major axis, minor axis, foci, and the eccentricity. Is this going to be stretched more in the x direction or the y direction? How come? The bigger number is sitting under y, so therefore it's stretched more in the vertical direction. Okay, so it's stretched really up and down. What is the location of the center? 0, 0. Your first two examples are not shifted. They are centered at 0, 0. How many units is it stretched in the y direction? 5. There you go. I take the square root of that number. So a squared is 25, so a is 5. Yep. How many units is it stretched in the other direction? 2. So already I have enough information to sketch this graph, and you can sketch your ellipse and make fun of yourself for how poorly you draw it. How poorly you drew it. All right, who can tell me the location of the vertices? 0 plus minus 5. Length of the major axis? 10. Length of the minor axis? 4. What do I have to do to find the foci? Move C units. How do you calculate C? A squared minus B squared is equal to C squared. Not exactly the Pythagorean theorem. It's a subtraction sign instead of a plus. If you want to see why that formula comes up, see me after class someday. I'll derive the formula for you. That's what we get. So I'm going to use a squared minus b squared to get c squared. What is a squared? What is b squared? So 25 minus 4 is c squared, so that would mean that c is equal to the square root of 21, or about 4.5. So I would move 4.5 units along the major axis. So the location would be 0 plus or minus the root of 21. Or you could write 0 plus or minus 4.5. That's where they sit. What's the formula for eccentricity? C divided by a, so you'd have the root of 21 divided by 5. A value is 5. What's that? Yep, so that would be about 4.5 over 9, which is approximately 0.9. So you can see, whoops, sorry, 4.5 over 5, and so you get 0.9, which is, this is a fairly stretched ellipse. Question. Eccentricity is how stretched it is. So if we saw a number like 0.1, instead of looking like that, it would look more like that, almost like a circle. Okay? So the more stretched it is, the closer this value is to 1. The less stretched it is, the closer it is to 0. 4 points. You should put the foci on there. Not the foci, other than that, you should be fine. What do you notice about this one? Yeah, it has to be set equal to 1. So I'm going to divide through by 36. What does my new equation read? X squared over 9 plus y squared over 4 equals 1. You go ahead and do the rest. Give me the direction. Give me the center. Give me the vertices. Length of the major axis. Minor axis. Foci. Eccentricity. And the graph. Really want to try to finish before the hour runs out because we have one more example after this. done, you can check up here. Your center should be 0, 0. The vertex should be 3, 0, and negative 3, 0. Your major axis should be 6. Minor axis should be 4. Foci should be plus minus the root of 5, 0. And your eccentricity should be square root of 5 divided by 3, which is, I think, approximately about 0.7. Okay. Okay, flip it over. I need to rewrite these notes. I have decided to spend less time on this unit this year. So what I used to do is show how to graph these on your calculator, because our ellipses functions, no, they don't pass a vertical line test. So how would you graph them on your calculator? We would spend time looking at that, but it's not essential knowledge, so I've decided to skip it and turn this lesson really one day. So let's do a shifted ellipse. X plus 1 quantity squared over 100 plus y minus 3 quantity squared over 64 is equal to 1. We're going to determine the direction, the center, the vertices, the major axis, the minor axis, the foci, and the eccentricity. We have until 1:08, so we got 4 minutes. Let's roll. Direction. Horizontal or vertical? Y. Bigger numbers under X. Center. Negative 1, 3. And it looks like I'm going to be stretched 10 units in the horizontal direction. So I'm going to make a graph over here, and I'm going to just go by 5s. Oh, to 15. I'm going to plot my center. Negative 1, positive 3. It's going to be a little bit tricky for us because we don't have all of our tick marks written down, but let's think about it. How many units do I move to the left and right? 10. Because the A value is 10. So if I move 10 units to the right, where will that bring me? From negative 1, if I move 10 units to the right, it will bring me to 9. So 9, 3 is one of my vertices. Then I move 10 units to the left. Where will that bring me? Negative 11, 3. This gives me my major axis. What is the length of that major axis then? 20. The minor axis we stretch vertically. How many units do I go up and down? 8. If I go 8 units up from 3, that will bring me to 11. So negative, whoop. I'm sorry, I don't have to actually list those, but I'll plot them. And if I go 8 units down from 3, that'll bring me to negative 5. I now have enough information to attempt to sketch this graph. What is the length of the minor axis then? 16. How do I find the foci? Yep. A squared, 100, minus B squared, 64 is equal to 36. So what is your C value? 6. So I'll move 6 units horizontally or 6 units vertically. Horizontally, because it sits along the major axis. If I move 6 units to the right of negative 1. 6 units to the right of negative 1. Where will that bring me? 5. And if I move 6 units to the left of negative 1, where will that bring me? Negative 7. My eccentricity will be C, which is 6, divided by A, which is 10, which is 0.6. We did 2 that were at 0, 0. We did 1 that was shifted. Assignment. So centered at 0, 0. angles are shifted. Might be a couple in there that involve a fraction or two. Some of you are predisposed to not liking fractions. I understand that. We'll do our best with them and go from there.